Functions are the bread and butter of any data analysis session. They're blocks of reusable code designed to perform a specific task. For example, we might use functions to calculate averages of our variables, summarize datasets, and conduct our statistical tests. R comes pre-installed with many functions that allow us to perform a variety of tasks. With these built-in functions, we can conduct comprehensive data analysis more efficiently, applying the same operations across multiple datasets with minimal effort. You can think of a function like a pipeline. We first provide it some input. This will be a piece of data, such as a data frame. Then the function will do whatever it's designed to do, such as calculating an average or doing some other type of data transformation, and then it will return to us an output. The output will of course depend on what the function was designed to do. For example, if the function was designed to calculate the average, such as a mean, then the input would be a piece of our data, such as a vector. The function would then take our vector and calculate the mean value. Applying a function in R uses the following syntax. First, we will use the name of the function that's being called. This will obviously change depending on what function is that we're using. Then we will open some brackets, which tells R that we're now starting to apply the input to the function. The information that we pass to a function is known as an argument. Most simple functions in R only accept one argument, but more complex functions that we're going to show you in a moment accept two, sometimes even more arguments to that function. We then close the bracket to say that we finished passing the information and the function can now run. So I'm now going to show you how to use some very simple functions in R. But first we need some data on which to apply the functions to. So let's pretend that I've just run a study and I have 10 participants in the study and I've logged the ages of each of those 10 participants. I've stored those ages in a vector and then I've stored that vector to a variable called participant ages. Let's say I want to calculate the mean age of those participants. The function name that I would use is called mean. Recall that we first use the function name and then we open some brackets. This is telling R that we're now going to provide the input to the function, in which case this is the data that we want to apply this function to. So we put in the brackets the name of the variable that we want to apply that function to, in which case this is the variable participant ages. Then we make sure the brackets are closed and then we can run that particular line of code and it will return to us as output the mean age of those participants. One useful aspect of functions in R is that they all come with their own help files. You can access this by typing question mark followed by the name of the function and then just running that line of code. What it will do is it will open up a help file in one of your RStudio windows and it will give you a description of the function, what it's designed to do, and also show you how to use that function, including all of the arguments that you can pass to that particular function. You will notice in this help file that the mean function actually takes multiple arguments, but we only used one. So there's lots of arguments that we could have passed to this function that we didn't use. You can think of a function like a basic calculator, in that there are other buttons on the calculator that you don't really need to use for the particular calculation that you're wanting to do in the moment. So just because those buttons are there, it doesn't mean that you need to use them. And the same is true for functions. Just because there are additional arguments, you don't always need to use them. So in this example, we've calculated the mean of our participant ages, and it's just returned the mean age as output to our console window. But of course, just like anything else in R, we could have saved this to a new variable if we wanted to. So we could create a new variable called mean ages, and we want to put into that variable the mean of our participant ages. So if we do this, then we've created that new variable called mean ages that stores the output of the function call. There are of course many other functions that we could have applied to this data. For example, let's say we didn't want to calculate the mean age, maybe we wanted to calculate the median age. In which case we would just call the median function, but again put within it the data that we want to apply that function to. We could also calculate the minimum age within our participants by using the min function. So the minimum age was 18 and we can verify that's true. So the second participant was the youngest and that has returned correctly. We could look for the maximum age of our participants using the max function. And we could look at the range of the participant ages. What is the min and the max value by using the range function on our participant ages data. And that returns 18 to 35. And again, we can verify that. The youngest age in the dataset is indeed 18 and the oldest age is indeed 35. We can also use slightly more exotic functions on this type of data. So for example, let's say we want to return all unique values within that vector. You'll note here that we've got a repetition of age in that 2 of our participants were aged 31. So if we wanted to return all of the unique ages, we could use the unique function. and pass again to it. And it returns all of the values that are unique within the vector of ages. We could also sort the data from youngest to oldest and from oldest to youngest using the sort function. So we use the function name sort, open brackets, and then pass to it the data that we want to use. And we'll see that it is now arranged that vector from lowest value to highest value. So the sort function is probably a good one in which to dive a little bit deeper and look at argument names and also how to pass multiple arguments to a function. First though, let's have a look at the help file of the sort function. So we just type in $sort and it will open up the help file in the RStudio window. And we see that it takes two arguments, one called x and one called decreasing, which is set to a default value of false. So if you go a little bit further down into the help file, it will explain what these argument names mean. So x refers to basically the data that you're passing into the function. So it can be numeric, character, or a logical vector. We talked about these types of data elements in a previous video. In our case, we passed to it a numeric vector, but it also has another argument called decreasing. And this controls whether the sorting function will return increasing or decreasing values. So before I show you how to apply multiple arguments to a function, I'm going to first show you how to use these names in a function call. This is often useful when there are multiple arguments that you could pass to your function. So before, what we did is we used the sort function, open brackets, and then just passed in the participant ages. This is the argument x. This is the data that we're passing to it. So what we could have done also is typed x equals participant ages. What this tells R is that we want to use the sort function, and then for the x argument, we want to pass to it the participant ages. And if we run this, it operates exactly the same as before. But this is useful when we want to apply multiple arguments to the data. So at the moment, we see that decreasing is false because it's not returning as output decreasing values. And that's because of this decreasing argument. So we can pass multiple arguments to a function using a comma to move on to the second argument. So we're going to use the second argument, which is decreasing. That's the name of the argument. And what do we want to set this to? So at the moment, it is set to false. And we can find this by looking at the help file. We see that decreasing is by default set to false. And this is why decreasing does not occur. If we want decreasing to occur, we can change this to true. So we're now using exactly the same function as before, the sort function, but we're now passing two arguments. The first is the x argument, and we're passing to that the participant ages, which is our data. And the second one is the decreasing argument, and we're setting that to the value true. This is a logical data element. So if we now run this, we see that the output is now a decreasing set of values. And that's because of this second argument that we've set to decreasing equals true. So that was a very brief overview of how to use basic functions in R. In the next video, we're going to introduce packages. These are free to install extensions to R that provide hundreds more functions to enhance the usability of R for statistical analysis. Cheers.